Welcome back, everybody. We are now going to move into our excellent student presentations. We have 7 talks this afternoon. Again, lightning talks from our students. Students, keep it short and sweet. And if there's time at the end, you can have a few questions. If not, folks, put your questions in the chat box and the students will address them as they have time. So with that, we have up first, Julianna Tresca from UNC Wilmington. And she's going to be talking to us about best management practices for coastal communities. So Julianna, take it over.
Thanks, everybody. Hi there. So I'm Julianna Tresca, and I'm presenting on best management practices in coastal communities. I'm from the University of North Carolina, Wilmington, and my co-partner for this research project is Alice Arquinive. And so why I chose this project, I'm from New Hanover County here in North Carolina, and we are definitely a coastal community and a coastal town. Pretty much we're surrounded by water, whether it's from the Cape Fear River or the Atlantic Ocean. And we've noticed over the past 5 years that I've lived here that multiple best management practices have been installed in this county over the past few years. And we wanted to see really if these best management practices or BMPs are really doing their job improving coastal water quality in our community. So for any guys that don't know, this yellow highlighted area is New Hanover County. And we are a coastal community, so water quality is important, whether it's through recreation on our river in the Cape Fear, or whether it's through bathers during the summertime in the ocean. And so improving and maintaining water quality is important not only for our economy, but also for the health of our community in general. And so for any of you guys that don't know, what are best management practices? They can be multiple different measures. They can be rain gardens, stormwater cisterns. All of them help filter out stormwater runoff and pretty much filter out those pollutants before they reach our surface water systems and those waterways. This is an example of a rain garden right here. And through all these impervious surfaces, they're picking up all these pollutants from our driveways, our roofs, and through our roads as well, and filtering out those pollutants. So our hypothesis was that BMPs in New Hanover County are worth the cost-benefit analysis and are worth being implemented in our community. And they do have a positive social impact for coastal tourism in New Hanover County. So our main project goal areas were Hewlett's Creek, Whiskey Creek, and Bradley Creek, which are these coral areas over here in these coral hues. And for our analysis timeframe, we looked at about 5 years worth of resolution spatial data. And our main goal was really looking at the effectiveness of urban stormwater mitigation measures and stormwater volume contaminant transport in New Hanover. And so I'm going to be going more into depth with these maps. So I just want to give you a general idea of what it is that we were looking at. And so we were looking at the main concentration of BMPs, which were maintained around these 3 target watersheds. And of these 29 diverse BMPs that were installed, they composed of 18 different types. And so the main methods that we were looking at is through geospatial satellite data and ArcMap layers as well. Hewlett's Creek, by far and large, had the most number of BMPs at 15. And composed one of the larger areas of the watersheds, which are all these different southerly lines within New Hanover County. We also looked at the more in-depth so we have 15 BMPs in this watershed. What are they composed of? Backyard rain gardens, retention areas, stormwater wetlands, and whatnot as well. So through LiDAR geospatial data, we were able to look at the depth of the BMPs, and then through aerial imagery, we were able to calculate the area of these BMPs. And so by combining and multiplying them together, we were able to figure out pretty much the stormwater volume. And so we were able to figure out how many stormwater BMPs are in this watershed, and how much volume is it able to filter out and pollutant contaminant transport through this methodology. So the main results that we found was that obviously Hewlett's Creek watershed had the most BMPs and was able to filter out the most stormwater volume. And we looked at also the different locations of the BMPs, because for the area watersheds that might not have the best water quality, what are some possible locations for installing these BMPs in the future? And so we want to look at the locations, and we also utilize LiDAR data for this information as well to see what are some low-lying areas that would make sense for BMPs to be installed at, and the location to surface water bodies as well. So we utilize that. So the main things that we really found was number 1, pet waste was the most number 1 water pollutant contaminant for New Hanover County. And if anyone's familiar with New Hanover County, so many people have dogs and cats. They're not always great about picking up after them as well. And so that really contributed to the fecal coliform contamination. So all these red squiggly lines you can see are surface water systems. So there are streams, are rivers, and they are impaired. And so we were able to figure out that through our data. And then the gray squiggly lines, we didn't even have enough data to be able to perform any analysis on it. And so what we really found was that despite them being impaired, the areas in the watersheds that had the most BMPs had the best quality of water, but they're all not meeting the standards that they need to. And so what we found was that Bradley Creek and Whiskey Creek in particular watersheds are going to be great target areas for installing more BMPs and overall improving water quality. They are doing their job, we just do not have enough of them. And so they're doing different initiatives such as the Bradley Creek Water Restoration Project, which is helping to improve these issues. But we need to have more data on this, especially in the targeted gray areas, so that we can continue this research and continue to learn more about improving water quality within these coastal communities. And so I'm going to stop sharing and switch screens real quick to show you a really cool WRRI story map that we've been working on as well. And so this one's pretty fun. It's a little bit more interactive. So we did an WRRI collector route within Hanover County. I just want to show you all the different types of BMPs that we do have. This is Bradley Creek Elementary School rain garden. We have different stormwater wetlands throughout the county, stormwater cistern, New Hanover County Government Center, for example. Tons of different types of permeable pavement throughout the county. This one's at Alderman Elementary School. The Fort Fisher Aquarium, they have a backyard wetland. Both on and off campus, especially around UNCW, there's been a lot of rain garden installations for helping improve the water quality in this area, and so much more. And then this one is pretty amazing. It's an ArcGIS analysis map, and it's very interactive. So as you can see, all these different triangle sections over here are actually shellfish growing areas, and we pulled a lot of data from those databases because they monitored fecal coliform, and if it got to too high of a level, they were shut down. And so we utilized a lot of that data. You can still see our study area watersheds here in Coral. And again, the red rivers are the ones that are impaired, and the gray, we didn't have enough data. And all these little Easter egg colored circles here are all the different types of BMPs throughout our target area watersheds. So we have cisterns, fire retention areas, backyard wetlands. Our study area watersheds are in coral. We have our tidal creeks here in green. We can click on these and we're able to see, oh, that's Bradley Creek. We're able to utilize different square mileage and whatnot. And then all of this yellow around the edges are the flood hazardous areas. And then we utilize also a hydrology layer that people can see, oh, this is where marshes are located, rivers and creeks. Really helpful in utilizing this analysis. And that's about it. If you guys have any questions for me, thank you so much for your time and attention.
Thank you, Juliana. We have a couple minutes if folks have questions for her about this BMP work from New Hanover County. Susan.
Yes, this was great. I really like those story maps and the GIS work that helps visualize things really well, which we of course know that's a great way to communicate, one of the greatest ways to communicate through pictures. Are there other states that have similar studies that you could compare your range to?
They more than likely do. It was pretty much a semester's worth of work on our end, and we're only able to utilize certain watershed data layers, such as from the Stormwater Department in New Hanover County. I think a lot of people, especially coastal communities, are experiencing similar issues with fecal coliform levels being higher than they should be. Ours in particular was mainly through pet waste, but I'm sure during stormwater events such as hurricanes, those levels are increasing from different measures such as CAFOs and hog waste farms in particular as well. So that would be definitely interesting to explore further.
Thanks.
Okay, thank you, Juliana. We will move now to the next talk. So we're going to invite Samrin Kusum to come give a presentation. She's from NC State, and she's going to tell us about fog deposits and what do we know and how do we fight it. So Samrin, take it away.
I hope you can hear me properly, right?
Yes.
Okay, all right. Good afternoon, everyone, and I welcome you all to my presentation. I'm Samrin, a PhD candidate at NC State University. I thank WRRI for this opportunity to present our work. Today, I'll be talking about fog deposits. What do we know and how do we find it? Before I start my presentation, I would like to show you this picture here. So can you guess what is this picture showing here? This is the inside of a sanitary swell line, and this gigantic solid attached to the swell walls are known as fat oil and grease, or in short, fog deposits. Now, you're probably wondering, where does this solid deposits come from? Well, the pathways of fat oil and grease starts at the domestic and restaurant kitchen sink, where after cooking, excess fat oil and grease are discharged through the kitchen sink and they ends up in the grease interceptor for separation. However, due to improper management of grease interceptor, a portion of this fat oil and grease ends up in the main swell line, where they can react with calcium to form fog deposits. And fog deposits can actually block the swell line and reduce its carrying capacity, and ultimately causes sanitary swell overflows. In the United States, around 3 to 10 billion gallons of untreated wastewater are released annually, 25% of which is due to the fog deposit related blockages, costing 25 billion of taxpayers' dollars to clean up. So we need to find out a way how to reduce fog deposit formation and its adhesion inside the swell lines. Literature shows that fog deposit formation requires two key ingredients, fat oil and grease, and calcium, both of which are already present in wastewater. However, calcium can come from the cement used in swell and construction materials such as concrete. And cement has two calcium components, calcium hydroxide and calcium silicate hydrates. Between these two, calcium hydroxide is not stable and can release calcium very easily. So to reduce fog deposit formation in our research, we are replacing a percentage of cement with fly ash. Now we are probably wondering why fly ash? Because fly ash has two benefits. It is very low in calcium content, and it can also convert calcium hydroxide to the stable calcium silicate hydrates through a pozzolanic reaction. So in this study, we developed 3 different concrete materials. One without any fly ash replacement, this will be our control group. And the other 2 where we replace 50% and 75% of cement with fly ash. After making these concrete materials, we ran fog deposit formation test. And for this test, we made the wastewater in our lab by using deionized water, oleic acid as a fog source, and canola oil. We also added calcium chloride to mimic the calcium that are already found in wastewater. And this fog deposition test was ran for 30 days. And after 30 days of this test, we found that for both the fly ash replaced samples concrete, we find fog deposit formation accumulation on the surfaces can be reduced by more than 55%. And as you can see from these pictures here, this control group has the highest amount of fog accumulation on the surfaces as compared to the fly ash replaced samples. It is at that time we also noticed that fog deposit does not adhere on the concrete coarse aggregate surfaces, which is granite in our case. So this leads us to study some factors such as porosity of swell and construction materials, pH near the surface of fog attachment, and surface roughness to understand the fog deposit adhesion mechanism. And to study all of these factors separately, we are using porous ceramic cups. And this porous ceramic cups is helpful because we can fill this porous ceramic reservoir with different pore solution to mimic different pH conditions. And finally, we measured the surface roughness properties using confocal laser scanning microscope that can give us different surface roughness parameters. And in this picture, you are seeing the porous ceramic cup 1 surface roughness profile, and this is showing the porous ceramic cup 2 surface roughness profile. And you can already tell that PC2 sample has higher surface roughness, right? And that is exactly what we found when we compared the 4 different surface roughness parameters. And for all of those surface roughness parameters, PC2 was higher as compared to PC1. After measuring the surface roughness, we ran the fog deposit formation test on these porous ceramic samples again with different pore solution. We used 2 different pore solution, pH 12.6 and pH 7. And all these samples has the same synthetic wastewater, and this is for PC1 and this is for PC2. So we know that these two have two different surface roughness. So what we're trying to do here is that by comparing the same surface roughness for this PC1 sample, which is 2.41 micrometer, when we look at the two different pH condition, we see for both of these test condition, we do not see any fog particle accumulation on the surfaces. However, this milky white solution here proves that fog particle actually produced, but they remained in the solution. On the other hand, when we look at the surface roughness 4.53 for PC2 samples, for both pH conditions, we see fog accumulation preferentially taking place on the surfaces. However, for 12.6 pH, we see higher accumulation on the surfaces as compared to pH 7. So what does this mean for us? It means that pore solution pH and surface roughness both play important roles in fog deposit formation adhesion. And higher pore pH and high surface roughness actually accumulates more fog on the sample surfaces. So what do we learn from the fly ash replacement is that fly ash replacement can not only reduce the calcium leaching, it can also reduce the pore pH of the concrete materials. As a result, we see lower accumulation. Also, when we compared the granite surface and the paste surface roughness, we found that granite surface roughness is lower as compared to the paste surface roughness. And also granite does not release any calcium. So as a result, with fly ash replacement, we are ensuring that we have low surface pH, low calcium availability, low surface roughness, and then that's why we are getting lower fog accumulation on the surfaces. Thank you, everyone. If you have any question, I'd be happy to answer.
Excellent, thank you. There's time for questions. So the floor is open or the chat box is open. Please put your questions in there.
Samrin, how large an issue is fog for municipalities?
It's a larger issue for urban areas actually, because with growing number, we have seen that from 2013 to 2020 already there is like a exponential growth in restaurants and people are actually eating outside. So with increasing number of population and increasing number of food service establishment, we are seeing increased amount of fog discharge to the swell lines. And as we know, this swell lines is already old and it already have very like exposed surfaces inside, so that incorporates like higher amount of surface roughness. So with time we're seeing like higher fog accumulation problem inside the swell lines as the time going up.
Thank you.
And there was one question in the chat box which is asking, what is the practical application of this work? So where do you see this being used out in the field?
Well, as I already mentioned, that many of our existing swell line system needs rehabilitation or maintenance. So when we are going to use like liner or any kind of concrete where we need to use cement, we can replace some of the cement with this low calcium fly ash replacement materials so that we can see lower calcium leaching and low fog accumulation. And also some of the swell lines need new construction. So as we know that fly ash is 1/3 of a cost of cement. So this will also be a cheaper construction for the alternative soil and construction materials.
Excellent, thank you. Appreciate your chat. And now we will move to the next student. We have Matt Ungaro from UNC Chapel Hill, and he's going to chat with us about policy from the stream bed up, assessing the regional stream policy's effects on river and wetland impacts. So Matt, take it away.
Thank you. Yeah, I appreciate it. Thanks so much for having me here. I'm going to be talking about, policy, specifically stream policy and stream policy in Texas. I'm a student at UNC Chapel Hill, working with Todd Bendor in the city planning department, but my department is the environment, ecology, and energy program. So yesterday we heard a bit about stream restoration. We heard from Dr. Paul and from Jackie about stream restoration, pros and cons and issues. But I wanted to talk about a little bit how the stream restoration market works and also how the wetland market works. So in the United States, we have an interesting thing where the U.S. Army Corps of Engineers controls impacts to waters of the USA. So for example, if let's say a company like Kroger wants to impact a wetland, they can't just go out and do that. They have to actually get a permit from the Army Corps of Engineers. And then after they do that, they actually have to go and purchase credits from a wetland mitigation bank, or they actually have to do it themselves. They actually have to do the restoration or the different actions themselves. However, these days, most of the time, it's a lot easier just to go to these mitigation banks. And these are private companies who do their own restoration work. So Kroger will go to this wetland mitigation bank. They'll purchase 50 acres worth of credits. And those credits will then go, the money will go into a restoration project. And if you notice, 25 acres damaged, 50 acres restored, the idea is that a lot of these wetlands may not get to the ecological level that they should be at. So this is kind of to at least get a decent amount of wetlands restored to their proper working ecological condition. And the idea is that then there will be no net loss of functions for waters of the USA. So back in the day, or historically, it was really only wetland mitigation that occurred. But recently, since 2008, the Army Corps has been engineering stream mitigation. And stream mitigation, as we learned from Dr. Paul and Jackie yesterday, it's an imperfect science. There is still a lot that needs to be learned about how to make it how to allow for lots of species to thrive in these restore streams, for example. But at this point, the Army Corps considers it ecologically successful enough, or at least successful in providing like space for people to enjoy the natural resources of these restored streams, to where restoration has been given the go-ahead from the Army Corps. So right now, most districts don't have a specific policy promoting promoting stream bank development. But in the Fort Worth district, I'm looking at this policy called SMM, where stream mitigation is actually being promoted, and they're doing it in a way to encourage high prices for stream restoration. And then 50% of the stream impacts that are occurring, so 50% of everything that's getting impacted needs to be mitigated with credits from a stream bank. The other 50% could come from a wetland mitigation bank. The idea is so that there's a market for streams and a market for wetlands. And so my question is, what effect does prioritizing stream mitigation have on the market? And can local stream policy effectively change the market, but also still protects streams? Because as we know, natural streams do a lot more work ecologically than restored ones do. So trying to preserve as many as possible is pretty important. So my location is Texas. I'm looking at the Upper Trinity River Basin, which is this little blue box here. And that is the Fort Worth, Dallas area. And my methods were that I gathered this Army Corps of Engineer data. The data is broken up into two parts: the records of planned impacts of streams, of wetlands and lakes, and then also the record of planned mitigation. So this is like the mitigation banking information. So I use generalized linear models to understand the change in stream impact demand, the change in wetland impact demand, the change in demand for stream credits. Those credits are, once again, are for restoration, and then the change in demand for wetland credits. So just three things I'm going to show you right now. I'm just going to show you a couple of graphs that I have. And on the left side, we have the demand for impacts. Okay, so this is, once again, this is the demand on the side of these developers. Okay, they want to go out and damage a wetland. How how much in demand is it to actually do this? And this is specifically for stream impacts per month, and that's in linear feet. So linear feet of streams impacted. And then on the x-axis, we have months from 2007 to 2019. And then the line down the middle is the impact of the SMM policy. And if we can, we can see here that before the policy came into effect, there was more and more impacts on streams occurring in this market. But once the policy came into effect, we started to see decline in the amount of impacts on streams, which is great if you are interested in keeping these natural streams preserved, because you want to see less impacts on these stream resources. So we also did this for wetland resources, and we did not see any real change, though we did see the average decline in terms of the amount per month, but it was still too variable to really make a conclusion. Finally, we have wetland credits purchased per month, or I should say secondary. We have wetland credits purchased per month of the y-axis, and then months from 2006 to 2020. We see an increase in demand for credits, and then we see a decline, and that's probably because now stream credits are part of the market. And then also we discovered that wetland mitigation banks are raising their prices too, so they're making it more expensive to go out and impact wetlands, which is good if you want to be preserving wetlands. And then finally, we stream credits really only started after the policy came into effect. So if we see here, we see stream credits purchased per month on the y-axis, and then months from 2014 to 2020. We see an increase in the amount of stream credits purchased, and then we kind of see what probably is some sort of stabilization in the market, where there's no more, or where we're not seeing these big, huge jumps, but the market is getting used to having these stream mitigation banks. So in conclusion, it seems like the Fort Worth district appears to have created a stream mitigation market while encouraging environmental protection through impact avoidance. And thank you. Let me know if you guys have any questions.
Thank you, Matt. Questions for Matt? And as folks are typing, Matt, I'm going to ask you, how do you see this translating to North Carolina?
That's a great question. I think in North Carolina, I don't know all the specifics of the market here in North Carolina, but there is already a strong stream mitigation market. So I would assume that they probably maybe don't need a push that they might need here in Texas. Before the policy came into effect here in Texas, there were no stream credits. Well, I know that I believe North Carolina has been doing stream mitigation, stream restoration for a long time. So my guess would be they might not need it, but it would be interesting to see if they would put in some sort of local policy where they were actually prioritizing stream mitigation along with wetland mitigation.
All right, thank you. Last chance to ask Matt a question. Seeing no raised hands and nothing in the chat box. Matt, you must have done a good job explaining it to everybody.
Thank you guys so much. I appreciate it.
Thank you, sir. Let's move now to Catherine Otero from Duke University. And Catherine's going to be telling us about North Carolina newspaper coverage of drinking water disruptions. Interesting topic, Catherine. Take it away.
Thank you for that introduction, and thank you everyone for being here. So whether it's in your mailbox, in your inbox, or in your news feed, local news still plays an important part in getting information to local communities. And local news is an important source of how people find out about water disruptions in their communities. And so we were interested in finding out how disruptions of water delivery or quality are covered by North Carolina newspapers. So why should we care about this newspaper coverage of disruptions? Well, the local news covers the official announcements of things like boil advisories, and also has discretionary coverage of things like water main breaks in town. And water infrastructure what should be underground or outside of neighborhoods, so it can be out of sight, out of mind. And this coverage provides visible signals to people about their water systems and possible issues with this. And so when I say talk about water system vulnerabilities, I'm talking about things like aging infrastructure that can lead to disruptions in delivery and quality. And so we were wondering, under what conditions do boil advisories get published? And so just to clarify, we are thinking about this from the newspaper coverage angle. So no, we're not actually looking at where these incidences are occurring. So to do this, we did a web scrape with keywords like a boil notice, boil advisory, to fetch the data from online. And then we manually coded it in Excel using things by location and incident type and date. And then we ran some descriptive statistics in R. And since this is really preliminary research, we just wanted to talk about some limitations. So we were only able to use newspapers with an online presence. And then also not all of our papers were represented across our entire sample time. And then not all North Carolina was represented in our data. And we also don't know the subscriber numbers or the number of clicks on these articles, but while we're still getting an idea of what coverage means, we do think the data tell an interesting story thus far. And so a definition of a unit for this research is one water-related incident. So this could be a boil advisory, a water main break, or a boil advisory being lifted. But we break it down to this one water-related incident because we had some articles that had multiple incidents within them. And so we broke that apart by the location and the type of incident. And so some of the basics, we had 293 observations, and this is from 2006 to 2019, from 37 newspapers in 46 of North Carolina's 100 counties and 98 water systems. So now getting into some more visuals, we can see here that there has been an uptick in recent years of coverage. And you can see a big spike in 2016 with Hurricane Matthew. And you can see another big spike in 2018 with Hurricane Florence. And so this drives us to wonder, is it just because more newspapers are publishing online, or is coverage actually increasing? And if so, why? And these are questions we don't have the answer to yet, but we're excited to dig into more as we go along. And then we also broke down our data by the incident type. And so you can see that overwhelmingly boil advisories were the most frequently covered. And then you see next is the water main breaks. So those are water main breaks that then weren't associated with a boil advisory following them. So we broke down the boil advisory types further into, you can see that the issuance and the lifting of boil advisories are the most frequently covered. And we believe this is because those are likely the official notices that are going out in the newspapers. And then also these advisories continuing, which were also frequently covered, those often came with weather updates. And so we also broke it down by the event causing the incident. And so here we saw that infrastructure was the most frequently covered. And so that infrastructure involves things like the water main breaks or water valve malfunctions or other infrastructure issues that then led to the incident. So these are the events that kind of triggered the water incidents. And then I also broke apart hurricanes from other weather events, just so you could see how frequently these water incidences were associated with hurricanes. And then also broke it down to show you that when the infrastructure was the kind of trigger event for the water incident, that was the focus of the article. Whereas when it was hurricanes were the trigger, it was largely seen in a larger, longer article that also had things like where to find food and shelter, and then the boil advisory or other water incident was just part of that coverage. And so what is an implication from this? We think that newspaper coverage of drinking water disruptions can represent a potential policy window. So when people are receiving this visible signal about their water system and it's on their minds, they may be more willing to take action on water policy, such as voting to increase taxes, to pay for water infrastructure improvements, or agree to water price hikes. And going forward, we're excited to connect this data with state data on boil advisories and then other data on water system vulnerabilities, so we can continue to see how these signals that people receive about their drinking waters relate to other measures of water system vulnerabilities. And I'd like to thank Emily Bell and Megan Mullen for their help on this project, and WRRI for the funding. And now I'll take questions.
Thank you, Catherine. Questions for Catherine? We have a couple planners on the call, so maybe they're pondering what they want to ask you.
I have one question, if that's okay.
Please.
Yeah.
So when you collect this data, did you normalize the data by like how many newspaper are mentioning the same events, or you just like if there is 10 newspaper mentioning the same news, you counted it as 10? So I'm saying, like, did you normalize this data?
No, we did not. And actually, like going through it, we didn't have too many incidences of the double up, but when we did, we just left them as separate incidences, yeah, or observations in this case.
Thank you.
Mhm.
And Catherine, in the chat, we have a question of what are the next steps? What about other media options like social media or next door groups?
Yeah, we haven't considered going into that data yet, but would definitely be interesting to see as people kind of are moving towards that, especially next door and other social media. Right now, we're focusing more on going into that state data on boil advisories and other kind of metrics of water system vulnerabilities, but interesting stuff to think about with the social media for sure.
Okay, last call for Catherine. All right, thank you, Catherine. Very interesting.
Thank you.
And now I will call to the stage Will McKeel from ECU, and he's going to be chatting with us about supercritical water desalination, experimental and modeling. Will, take it away for us.
Hey, can you hear me?
Yes, sir.
How are you today?
Excellent.
Just a second. All right, so hello all. I'm Will McKeel, and I am a mechanical engineering graduate student from East Carolina's engineering department. I'm working on a project involving zero liquid waste desalination using the technique called supercritical water desalination. The project is funded by the University of North Carolina's System Research Opportunities Initiative, which is an ROI grant, and the project is multidisciplinary, including a couple multi-institution collaborative initiatives. We also have 7 different PIs and co-PIs, and I'm working underneath Drs. Duba Filho and Dr. Salam from East Carolina University. So, as you all know, lack of potable drinking water is a major issue emerging today. The World Health Organization estimates that up to 20% of the world's population has experienced some form of water stress. The World Resources Institute has said that 37 countries face an extremely high level of water stress. And they also put the United States in the medium to high stress category. So a question there is, so what's being done to combat the water stress? A lot of cases, desalination is being done. So in 2020, there were nearly 20,000 desalination plants worldwide. And of those, roughly 69% were reverse osmosis. But utilizing reverse osmosis for desalinating brackish water, it is highly effective with the recovery rates as high as 93%. But when it's used for seawater desalination, the recovery rates average about 50%. So apart from the low efficiency of conventional desalination methods like reverse osmosis when using seawater, the main challenge that we really face is what do we do with this even higher concentrated waste that is produced from the reverse osmosis process? Well, in most cases, it gets treated, but then it gets discarded directly back into the environment. There's really nothing further that the reverse osmosis process can do with it. But when it's close to the ocean, which is the case with most seawater reverse osmosis plants, it's usually dumped directly back into the ocean. And the reason for this is that most of them are installed and operated near the ocean for economic reasons, but the locally elevated salinity from the concentrated brine waste during the plant operation creates significant environmental impacts and threatens the marine ecosystem. So then we come into Eastern North Carolina and East Carolina University because we lie in a unique position to aid in this problem. So in 2011, the beaches of North Carolina had reverse osmosis capacity of around 35,800 meters cubed per day, along with Southeast Virginia had roughly 60,000 meters cubed per day. And most of these plants operate in the 2,500 to the 10,000 parts per million range of input capacity or input TDS. But you also have one plant on the coast that operates in the greater than 10,000 parts per million range. So you put it in perspective, within 3 hours drive of Greenville, you have nearly 100,000 meters cubed per day of reverse osmosis plants. So then you go into our research. The ECU Water Energy Nexus team as a whole is developing a sustainable water desalination system with a zero waste discharge. What you're looking at here is a flow sheet of the system being developed by us. The team currently has designed and built the system, and we're now working on testing of the continuous pilot scale supercritical water desalination system. We're looking at a capacity of about 0.16 liters per hour, and it's going to treat brine waste from reverse osmosis plants. What we expect to see is an input TDS or percentage of salt concentration around the 5 to 10% range. The system is also expected to operate off-grid by integrating the reverse osmosis and supercritical water desalination techniques to convert seawater into clean water and solid crystals. So we're also looking at adding in renewable energies in the form of wave and solar energy, along with power or regenerative energy through the use of a supercritical CO2 Brayton cycle, which we're looking at being able to integrate that to help power the system so that it can be operated completely independent of grid energy. The main objective is of being able to fully separate the salt crystals from the water. We think will be extremely beneficial for disposal purposes, since liquids are inherently more costly to transport than solids for further processing. And there's also a possibility of being able to separate the solids for other commercial uses as well. The supercritical water desalination process requires further advancements like mechanistic understanding of salt precipitation, process optimization, corrosion control, and process scaling issues. Thus, we'll be looking for graduate students and research collaboration opportunities. With that, I want to thank you for the opportunity, and I'll take some questions.
Okay, thank you, Will.
Yeah, thank you.
Questions for Will on this process for dealing with the brine from reverse osmosis plants?
Will, thank you so much. This is really interesting. Are there, from like a national perspective, what are other communities or large municipalities doing with their brine?
In most cases, what happens is it gets treated to remove some of the bad stuff that doesn't need to go back directly into the environment. But all the salts typically, they're in a higher percentage range than they came in. They just typically get either pumped back deep into the ground through deep wells, or if it's close to the ocean, it gets put into the ocean.
All right, thank you, Will. I appreciate the presentation.
Thank you.
I will call to the stage now Brock Kamrath from NC State. And he's going to tell us about nitrogen release from minor wastewater treatment plants in North Carolina without nitrate monitoring requirements. Brock, you are up, sir.
All right. You get this going. Okay. I just want to say hello. Thanks for that introduction. It's great to be here. I am Brock Kamrath. I'm a PhD candidate at NC State. I work with Dr. Burchell in the Biological and Agricultural Engineering program. And today I will be discussing nitrogen releases in North Carolina, and more specifically, as my title suggests, the potential for unaccounted for nitrogen release from minor wastewater treatment plants. So to give a little background on this issue, there are about 400 wastewater treatment plants with MPDS permits treating either municipal or domestic wastewater in North Carolina. Of those 400 wastewater treatment plants, there are actually only about 185 with nitrate monitoring requirements. So there's only 185 of those plants that actually have to monitor how much nitrate leaves in the effluent. And then of that, there's an even smaller number, only 6 of them actually have discharge limits for nitrate, and where they have to actually cap the amount of nitrate they can release. And to flip those numbers around, this means that there are about 200 wastewater treatment plants that don't have any nitrate monitoring requirements, and therefore we don't really know how much nitrate they release. Most of these are minor wastewater treatment plants with less than 1 million gallons per day, so it's usually not the larger plants. And the rationale behind this is that most of these permits are focused on ammonium reduction. Every single one of the 400 wastewater treatment plants are monitored for ammonium, and more than 300 of them have the discharge limit. So they are more focused on the ammonium form of nitrogen than the nitrate form. And that's because this ammonium is toxic to aquatic health. But what does this contrast between stringent ammonium requirements and relatively lax nitrate requirements mean for nitrogen loadings and nitrogen discharges from these plants? And it means that these plants are kind of incentivized in the way they operate to focus solely on ammonium removal. If it doesn't matter how much nitrate you release, you really just want to remove the ammonium. And they do that mainly through focusing on nitrification. And now that nitrification doesn't actually remove the nitrogen, it just converts that influent ammonium to effluent nitrate. And we can actually see in some of the wastewater treatment plants that actually have that nitrate monitoring that this results in a fairly substantial nitrate effluent load out of these places. But what does this mean? Kind of what is the nitrogen release from the 200 or so plants without nitrate monitoring? And really the answer is we don't know how much nitrogen is released. We know how much ammonium is released, but the nitrate is still up in the air. However, we hypothesize in this study that with that nitrification focus and then that lack of nitrate monitoring, that these sites probably release a substantial amount of undocumented nitrate to our surface waters. In order to evaluate this hypothesis, we were able to get access to a minor wastewater treatment plant here in North Carolina. It's a relatively small facility. It only services about 250 people, and the design flow is low, about 0.1 million gallons per day. This is a site that doesn't have nitrate monitoring or discharge limits. It does have ammonia monitoring. And what we did was, while the plant was sampling for their MPDS permits in 2019, we were able to sample twice a month from the effluent line as well and analyze these samples for not just ammonium, but also for the nitrate, ammonium, and TKN as well. But So what would you see from their numbers if you wanted to go look at this? How much nitrogen did this site release in 2019? Well, if you went and looked, you would see that the site released about 157 kilograms, which, as you can see here on the site, that's about 347 pounds of nitrogen. And that's the only number you would have. You would just say that this site probably released around 350 pounds that year. Now, to contrast this, in our study, we found that the site actually released about 1,000 kilograms of nitrogen, which is about 2,000 pounds, with most of that coming in the form of nitrate. You can see in this chart here, I have the cumulative 2019 load over every month, and their cumulative nitrate load or nitrogen load that they got from the MPDS permit is shown in red, while our loads for nitrate, ammonium, and then total nitrogen at the top in black are shown as well. And that total nitrogen load, like I said, was actually about 900 kilograms or about 2,000 pounds. So, what does this mean for us? Well, in terms of pure numbers, it means that this site likely released around 750 kilograms of unaccounted for nitrogen to our surface waters in 2019. To put that number in kind of perspective, that's around the similar amount of nitrogen export that you would expect from about a 50-acre tile drain cropland in the Midwest. That's about how much that would be. But really, in terms of our state and all of these plants, if this site is representative of other wastewater treatment plants without nitrate monitoring, that the unaccounted for load could be in the ballpark of 150,000 kilograms of nitrogen per year from these sites. And at this point, I do want to stop and say that they're doing nothing wrong here. I don't want to come down on minor wastewater treatment plants. This is the way the system is set up. But that being said, this does provide a great opportunity for additional nitrogen load reductions at these sites. These are maybe larger sources than we thought, and sources where additional nitrogen reductions could be achieved. And one example of this is you could take the site that we studied, and if you added about a half-acre treatment wetland to that treatment train, you could remove nearly 400 kilograms of nitrogen per year. And that's more nitrogen than we even thought it released. So that's one example of what we can do. Just to wrap this all together, it was pretty clear from what we saw that these minor wastewater treatment plants, without the monitoring, definitely have the potential to release unaccounted for nitrogen to our surface waters. More specifically, at this site, that release was an extra 750 kilograms of nitrogen, more than what was reported and what you would see. And with hundreds of similar wastewater treatment plants, that these sites may provide a unique opportunity for both improved nitrogen accounting in North Carolina, but also maybe improved nitrogen removal in North Carolina, which could be accomplished through low impact treatment systems such as constructed wetlands. So I just want to say thank you to WRRI for funding this research, and thank you all for listening. And I can take any questions.
Thank you, Brock.
Yeah.
Couple questions for Brock have already been answered in the chat. So thank you, crowd, for answering those and saving Brock the time. If there are other questions for Brock, we do have 1 minute before I'm going to call up the last speaker. So Brock, I'll ask you, since I'm curious, adding a wetland seems like you would have to have land availability to do that. So is that feasible in our state or not?
I think so. I don't know if you'd call it the beauty of it, but these minor wastewater treatment plants that we were looking at, these are typically in rural or suburban areas that often have land available around them that could be utilized for such a practice. So in this idea, yes, yeah, it could.
Excellent. Thank you, Brock.
Yeah.
And so with that, I will now call Michael Doyle, also from NC State University, up to the stage to tell us about fate and transformation of dissolved organic compounds in landfill leachate. Michael.
Thank you very
Lead us
much,
home.
John. Thank you very much. My name is Michael Doyle, and today I am presenting to you I'm a second year chemistry PhD student in the Baker group at NCSU, and I'm presenting this talk titled Assessing the Fate and Transformations of Dissolved Organic Compounds in Landfill Leachate and Wastewater Treatment Systems. Landfill leachate and wastewater pose direct environmental exposure risks to the immediate areas in terms of gases released into the air and water that leaches into the ground around landfills. Even when these risks are mitigated by proper containment, there's still the concern that the treated water poses indirect risks when it's released back into the environment as surface water and used in irrigation. Pollutants have been shown to crop up, to bioaccumulate in our crops and our marine food sources. Surface water seeps into the ground and refills aquifers that 99% of rural Americans and over half of the US population rely on for their drinking water supply. To mitigate our exposure to these harmful chemicals in water, we need to better understand the chemical composition of the water treated and released by water treatment facilities. Traditional water treatment quality control ensures safety through various metrics like absorbance, levels of ammonia, nitrates, phosphorus, and heavy metals, as well as pH levels. Unfortunately, these water treatment QCs do not detect or evaluate the dissolved constituents of the water. So this raises the question, what is in the water? And what can be done to evaluate these dissolved organic compounds in our water so we can limit environmental and human exposure? We propose leveraging liquid chromatography coupled with mass spectrometry, or LCMS, to shed some light on this murky water problem. In this experiment, we sampled 4 water treatment facilities in North Carolina. 2 were landfill leachate treatment facilities, LFA and LFB, and 2 were wastewater treatment facilities, WWB and WWC. We sampled water entering and discharged from the facility, as well as the water in the intermediate processes which are specific to each facility. As an example of those intermediates, here is the treatment layout for LFB. Each of the red labels indicate a location along the treatment chain that we were able to sample. So in this experiment, we are comparing the chemical profiles within each facility as well as the profiles between all of the facilities. First, samples were collected from their respective facilities. They were then filtered, acidified, and subject to solid phase extraction. The methanol extract was then analyzed by our Thermo Fisher Orbitrap IDX mass spectrometer, and chemical profiles were obtained. The raw data was processed in Compound Discoverer to extract chemical features based on isotopic distributions, and data analysis was performed in PMARC-R, an open source R package for omics data analysis. Samples were taken in parallel. So here we're seeing 31 samples and 31 replicate samples side by side. The samples are displayed here from left to right as water entering the facility, then the intermediate processes, and then the water being discharged from the facility. 37,826 features were found in common for all samples across all 4 facilities. And we were able to identify 1,273 of these features and assign their chemical identity using these 6 databases. From the plots, we can see that discharged water is much lower in abundance to the water entering or being treated by the facilities. We can also see that the landfill leachate treatment centers had much higher abundances of water going in and being treated than that of the wastewater treatment facilities. Here, we're looking at the results of an ANOVA test comparing the incoming water to the discharged water. Since so many features were being analyzed, we used a Holmes multiple comparisons procedure to control the family-wise error rate. The blue dots are statistically significant features that are being decreased as a result of treatment, and the red dots are those features which are increased as a result of treatment. We see far more reduced features and fewer increased features in the landfill treatment centers than we do in the wastewater treatment centers. We have reason to believe that this is due to reverse osmosis filtration that only occurs in landfill leachate treatment centers. A little more on that. Here we have a look at the reduction of chemicals as a result of each treatment within the facility. The full pie chart at the center of the figure indicates the total amount of identified compounds removed by treatment, and each slice indicates a specific chemical class. The outer circles indicate the proportion of each chemical class that were removed as a result of each treatment. So we can see which chemical treatments are removing the largest proportions of chemicals, and we can see if these filtration methods are more efficient in reducing certain classes of chemicals. As an example, the proportion removed in LFA between reverse osmosis concentrate and reverse osmosis permeate is larger than any other filtration step. We can see that this reverse osmosis filtration is also slightly preferential to benzoids, phenylpropanoids and polyketides, and organic nitrogen compounds. Compared to WWB, we can see that this reverse osmosis filtration removes a larger proportion of chemicals than any other of the treatment steps. In conclusion, we had over 30,000 chemical features detected in the landfill leachate and wastewater treatment facilities. Feature numbers were greatly reduced through multiple stages of treatment. Some features increased as a result of treatment. Reverse osmosis filtration caused the greatest reduction in chemical feature numbers. In the future, we would like to validate the chemical identifications we obtained using the MSMS spectra and evaluate chemicals of environmental and human health concern. I'd like to thank my PI, Dr. Aaron Baker, and everyone here on the right for their involvement on this project, as well as my lab members for their continued support. And thank you, all of you, for listening.
Excellent. Thank you, Michael. The floor is open to questions for Michael on his presentation. I'll give people a little bit of time to type, Michael, and if not, then I'll let you off the hot seat, but we'll make sure people have time to type in the chat box if that's what they're up to.
All right, thank you, John.
All right, well, you must have explained everything perfectly, Michael. So thank you for the presentation. And I'd like to give all our student presenters a hand for all the great work that they told us about today. And I will turn the conference over to Anna Martin for some important announcements.
Yeah, thank you so much, John. I just want to thank all of our keynote speaker, Veronica, all of our panel members this afternoon, and all of our student lightning talks. Again, just it's super unusual that I get to hear a lot of our conference material. You guys know that we do this in person, there's many hats and logistics to run, and usually I'm all over the place. So my feet are thankful today after day 2 that I can still walk around without a lot of pain. So the other thing about our in-person conference, if you guys have attended in the past, you'll know that we have a partnership with the North Carolina Source Collaborative Awards, our program. And today they would like to take a little time to present some awards that were originally scheduled for 2020 and the 2021 awards. So if you'll give me just a moment, I will get that started for you.
Good afternoon, everyone. My name is Brad Whitman, and I work with the North Carolina Public Water Supply section within the Division of Water Resources. I am honored to be here today on behalf of the North Carolina Source Water Collaborative to recognize our 2020 and 2021 North Carolina Source Water Protection Award recipients. I would like to take a moment and thank WRRI for allowing us the opportunity to present at their annual conference. Before I dive into the actual awards recognition, I would like to take a brief moment and provide a little background about the Source Water Collaborative, and in particular, the awards program. Founded in 2011, the North Carolina Source Water Collaborative is a statewide partnership to protect drinking water and includes participants from nonprofit organizations, university programs, state, local, and federal agencies, professional associations, and regional councils of government. The collaborative's purpose is to support strategies designed to preserve the lakes, streams, rivers, and aquifers used for drinking water, also known as source waters. The awards program was created in 2014 to support the collaborative's mission by acknowledging candidates and projects that demonstrate innovative, proactive, and collaborative solutions to protect North Carolina's drinking water and their associated watersheds. Since its creation, the awards program has been a yearly event with the winners recognized at this conference. Award nominations are categorized into one or more of 6 categories. These categories are groundwater planning, groundwater implementation, surface water planning, surface water implementation, education, and leadership. This is a screenshot of what the nomination form looks like. We ask for just some basic information about the applicant. We request that they provide the award category, some nominee information, a 1-page summary document to describe the project, in addition to up to 10 pages of supporting materials. For this past award cycle, our application deadline was January 8th, and it usually falls around that same time frame each year. This slide is just a demonstration of the geographic representation of our award winners over the years. 27 projects have been recognized since 2015. Due to the cancellation of last year's in-person conference due to COVID-19, we were unable to formally recognize the 2020 award recipient. Therefore, we thought it would be most appropriate at this year's conference to go ahead and recognize both the 2020 and 2021 award recipients. For 2020, we had 1 award in the leadership category. This leadership award is being presented to Ms. Rebecca Turner for her efforts with Hertford County rural water wellhead protection activities. Ms. Turner was instrumental in initiating the development of a voluntary wellhead protection plan to protect the water quality of 4 wells that serve approximately 8,000 people within the county. She demonstrated extensive knowledge of the water system and of potential contamination sources found in close proximity to the wells. It was very evident through the wellhead protection planning process that Ms. Turner had already considered and implemented many management strategies to address these potential contaminant sources. She worked alongside other water system staff to educate local entities, business operators, and the general public within the county of the importance of wellhead protection. For 2021, we have 2 award recipients. We have 1 Surface Water Implementation Award and 1 Surface Water Planning Award. The 2021 Surface Water Implementation Award is being presented to the City of Durham Department of Water Management in partnership with the Triangle Land Conservancy and the Eno River Association for their land conservation projects completed under the City of Durham's Water Supply Watershed Protection Program. This program was actually recognized and awarded a Surface Water Planning Source Water Protection Award in 2018 for efforts in creating a model that identifies and prioritizes parcels within the city's water supply watersheds that, if protected, would maximize source water protection. These parcels would be considered eligible for conservation easements or acquisition, partially or wholly funded by the City of Durham. The 2021 Surface Water Implementation Award is now being presented in recognition of funded land conservation projects, 3 with the Triangle Land Conservancy and 1 with the Eno River Association. These 4 projects have resulted in the protection of 298 acres of land and over 13,000 linear feet of streams. This land, identified in the City Water Protection Plan, contributes significantly to the protection of the city's water supply. The 2021 Surface Water Planning Award is being presented to the New River Conservancy in partnership with Jennings Environmental, Blue Ridge Conservancy, Middle Fork Greenway, Blue Ridge Resource Conservation and Development, and the town of Blowing Rock. Their project, Middle Fork New River Section 1B Restoration, is located in Watauga County, situated between Highway 321 and the Blue Ridge Parkway on both federal and town of Blowing Rock land. The Middle Fork New River is listed on the 303D impaired list, and Section 1B is considered highly unstable with eroding streammates and poor riparian vegetation. This section of the river runs by the town of Blowing Rock water plant, which is now being threatened by the severely eroded and meandering channel. A topographic survey, geomorphic assessment, and an engineering design have been completed aimed at restoring Section 1B. This approach will include the enhancement of the riparian buffer, realignment of approximately 1,200 linear feet of channel to maximize floodplain access and width, creation of off-channel wetlands for habitat and water storage, and the creation of an education area in the vicinity of the new river channel and wetlands. These efforts will ensure that the source headwaters of the new river will continue to improve and become more resilient to the development of the high country. This will conclude our awards recognition program. If you have any questions about the North Carolina Source Water Collaborative or the awards program, please feel free to contact me or my colleague, Danny Edwards, and we'll be happy to talk about that with you and answer any questions. And once again, we would like to thank WRRI for allowing us to present these awards at the conference. And we also want to congratulate, once again, our award winners. Thank you.
Yeah, thank you so much for pre-recording that, Brad. That was definitely an awesome way to incorporate a normal part or traditional part of our conference. So I know Brad is still on our in our meeting. So if anyone has any questions for Brad, please feel free to drop those in the chat box. And now we have an announcement winner of our own. So I'm going to pass it back to John for a few minutes and let him tell us who won the Student Lightning Talk competition.
Thank you, Anna, and thank you to everybody for sticking with us on this Friday afternoon. I am pleased to announce that Julianna Tresca from UNC Wilmington did win the competition from today's round of presentations. So Julianna, congratulations. And we will catch up with you later to make sure you are sent all the wonderful accolades coming your way. But again, congratulations to all our presentations. Everyone did a great job. And we're always excited when we can engage with students. And it's one of the hallmarks of this conference. And we're glad we were able to do it this year. So with that, Anna, I will throw it back to you to close us out.
Yeah, thank you so much, John. We do have our 22 dates scheduled at the McKimmon Center, but we hope to be back in person and doing the networking that comes along with this. We miss seeing you and being able to shake your hand, say hello, and hear about your awesome research. There's just so much going on. it's just eye-opening every time we do one of these to bring everyone together. So we hope you've heard some really good stuff. I want to remind everyone that there is an evaluation attached. It's linked on the bottom of your agenda. It's on our website. It was in a few emails that I've probably pestered you with. So make sure that you send us your feedback and tell us how we can improve. We're constantly striving to make it better and make it mold it to what you want to see when you come to these events. As well, I know that we have some PDHs and continuing education units available. So we have instructions on our website how to receive those, and I've already gotten a number of your forms back. So yeah, please pay attention to those requirements. And again, we appreciate your time today on a Friday afternoon, and thank you to everyone. Our team was awesome to bring this together, and we're so glad that we could present this program for you. So
Yes,
thank you.
Thank you all.
Yeah.
Anna's done a great job here. And there's babies included on that side. Everybody's got fresh water needs. So thank you all for joining, to our panelists and our student presenters both today and yesterday. And we will look forward to seeing you all one way or the other soon. Everyone have a great evening. Take care.